Top later. Rotation is not over. Gravitation is over. Top later. Okay. Mechanical properties of solids, right? When we start this chapter, you need to understand how is any material built. It is built up of molecules. And for let's say you have an iron bar. So it has iron molecules, and the distance between two consecutive iron atoms is called correct, intermolecular distance, or it is also called bond length. Very good, it's called bond length. Okay. So the thing is, two atoms. So let's say hypothetically speaking, I give you that the distance between two iron atoms in an iron rod is, let's say, 10 femtometer, 10 angstrom, let's say 10 angstrom. Okay. This number 10 angstrom, hypothetically, let's say it is 10 angstrom. The distance between the average distance between any two iron molecules will be 10, closest between two closest molecules will be 10 angstrom. If you try to make it 9, what will happen? The distance between two consecutive atoms is, let's say, 10 units. Okay. Now what you have to do to make it like if you want to try to make it 9, apply energy or force. What kind of force? A compressive force, a force which compresses, or a force which compressive, right? Correct. So that is called a compressive force. Okay. If you want to make the distance from 10 to 11, what will you need to do? Extensive force. It is also called tensile force. Okay, so these are names. Okay, now think about it. Why was the atom chose to, this separation was 10? Why was not it 11, and why was it not 9 or 15? Why was it 10? What factors made it? Which factors contributed to the fact that the distance, finally the equilibrium distance was 10? For a very good, that distance the molecule is stable. That means at any other distance not 10, it is unstable. That means whenever you try to make it not 10, it will want to go back to 10, right? Do you understand this? If the bond length between two iron atoms is 10, and if you, by any process, you can extend it or compress it, and you want to make it not 10, if you want to extend it, it will try to gain back, right? If you want to compress, if you try to compress it, it will try to extend back, right, to 10. So here, what is developed here, for a simple thing, this is called stress. What is stress? If you try to, एक iron rod है, so if you try to extend it, so this is, now I was explaining you on a molecular level, micro level बोलते हैं, क्या बोलते हैं? Micro level. What happens on a macro level is you see a rod length L, let's say 1 meter, and then you try to compress it with a force, the rod will extend, slightly extend. Okay. So this extension, let's say it extended by 2 centimeter. Then this extension is very low. Okay. On real life, a 1 meter is how much centimeter? 10 centimeter. Iron rod will not even extend 1 millimeter. Okay. It is very hard to extend an iron. Okay. But for representative purpose, I'll say 1 centimeter. Okay. So let's say extended by 1 centimeter. That means this extension जो आया extra, ये कहाँ से? Where has it come from? पहले तो understand this. ये has, how is? Are there more atoms which have joined? No. Has the mass of the rod increased? No. What increases?
So the thickness is reduced.
जोर से बोलो.
Thickness has reduced.
Thickness has, okay, very good. Thickness has slightly reduced, the cross section area, so that is reduced. It's an interesting thing what he has said. Okay, see, is it necessary that thickness, see, thickness reduced कब होता है? देखो, if you're saying volume is constant, then thickness is reduced, right? Yes or no? Now go back to thinking molecules. Okay, how has this extension happened? Extension कैसे हुआ? Two atoms which were at this distance have slightly moved like this, right? And all of the atoms have moved, no? So any two atoms like this, they are represented like this, right? And the next atom, जैसे तो ऐसा हो गया. So there is In two atoms, you have a separation of 2x, right? Do you really need to lessen the thickness of the cross section? No, right? We'll come to that. See. So in the mechanism by which I told you how the extension is happening, is there a need to reduce the cross section? No, right? There is no need to reduce the cross section. So is the volume increasing? Yes or no? Yes, by in this mechanism, volume is increasing. Is everyone getting it? The volume of the cylinder is increased. अगर ये cylinder है तो उसका radius same है लेकिन length बढ़ रहा है. Understood? बढ़ रहा है ना? तो volume increase हो रहा है, ठीक है? Now you have in general life you have seen कि जब आप किसी चीज को खींचते हो तो यहाँ से पतला हो जाता है ना वो इसलिए why is that you are so there is something called elastic limit we'll see till 1 centimeter 2 centimeter iron will extend its volume will increase its cross section area will not decrease and then there is an elastic limit which is reached after that you'll observe कि you know if you extend it further it will compress from there it will make ऐसा हो जाएगा okay understood so we have understood three things first the compression and extension which I'm talking in this chapter is between the atoms ठीक है atom themselves are not displacing ठीक है because if you want the cross section area to decrease the atoms themselves must displace right ठीक है तो ऐसे लेयर अगर ऐसे दो लेयर है तो एक लेयर आगे चली जाएगी तभी तो the cross section area will decrease right ऐसा नहीं हो रहा है बस there are two atoms which are just slightly displacing okay ठीक है second thing you have understood if you want to change if you try to change the equilibrium distance that the material will always resist right third thing which we saw is that there is no need to decrease the volume or keep the volume same you can also increase the volume okay and all this is valid till elastic limit okay now you have three things you have what is called as stress सबसे पहले stress is force by cross section area लिखो stress is force by cross section area one minute okay keep your videos properly everyone Harshal
Sir,
yeah Harshal keep
very
your
call.
no it's not proper keep your camera properly
Can you see me now?
hmm. Okay so we have some definitions to write okay I am showing the screen you'll write those definitions fine write this quickly to deforming force write them very 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 fast hand okay very fast hands actually I can explain you right now and you can write it later no just read them okay read them Don't write it. You will write it later, okay? Deforming force is a force which tries to produce a change in the configuration, okay? Elasticity. Elasticity is the property by which when you remove the deforming force, the object will go back to its original shape, size, okay? Elastic limit is that limit up to which the object will go back to its original state, okay? Fine. Perfectly elastic body, if they regain their original configuration immediately and completely after the removal of deforming force, okay? See, you have to remove the deforming force and then check whether the object is going back to its original shape and size or not. If it is going very quickly and completely, it is called perfectly elastic. If it is not going to original shape and size, it is called plastic. Okay. Okay. Now this, see, stress. What is stress? The internal restoring force per unit area of a deformed. ये इसका definition लिख लो. The internal restoring force per unit area of a deformed body is called stress. उसके बाद भी जो लाइन लिखे ना वो भी लिख लो. Stress is restoring force by area. Its unit is Newton per meter square and dimensional formula is ml. -12 लिखा हुआ है वो नहीं है. क्या होना चाहिए अपने से निकाल के करो. टेंसाइल क्वांटिटी क्या 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 टेंसर छोड़ दो वो छोड़ दो ठीक है no yeah 1 second
Sir, stress dimensional formula is ml minus 1 t minus 2.
हाँ ml -1 t -2 है ना डायमेंशन ऑफ कितना है ये गलत है डायमेंशन पता है ना ओके ठीक है ये लिख लो अच्छा एक चीज में वन थिंग इंपॉर्टेंट द इट इज कॉल्ड रीस देखो यहाँ पे एक इंपॉर्टेंट इंटरनल रिस्टोरिंग फोर्स ओके दिस इज इंपॉर्टेंट व्हाट इज द मीनिंग ऑफ internal restoring force opposite to it correct when you apply an external force the object will try to apply an opposite internal force okay and try to not deform that is called internal restoring force okay fine So usually it is equal to the external, numerically it is equal to the external applied force. Okay, if the external applied force let's say is, so देखो क्या होता है, तुमने ना 10 न्यूटन लगाया, मान लो ऐसे 10 न्यूटन खींचा, ऑब्जेक्ट इंटरनली 10 न्यूटन लगाएगा, ठीक है, इट विल ट्राई टू रेजिस्ट. हाउ डज इट रेजिस्ट? जो एटम्स है वो थोड़ा दूर होंगे तो उनमें फोर्स डेवलप होगा, दैट फोर्स विल कंट्रीब्यूट टू द 10 न्यूटन. नाउ यू मेक इट 20 न्यूटन, तो एटम और थोड़ा दूर होंगे and they will still try to resist. This is internal is 20. Okay, now you make it 50 newton, external 50 newton. Again the object will extend, the atoms will extend and they will try to balance it, right? Let's say the elastic limit reached at 80 newton. So okay, the moment you apply 81 newton, what happens? These two atoms can only apply 80 newton. Okay, so there is a residual 1 newton, right? That 1 newton will plastic deform the body. Now the body will not be able to go back. If you applied 50, right, and the atoms were under stress, if you remove that 50, they will go back to, the original distance. Understood? This is called elastic limit. If you apply the force, external force below the elastic limit, at any point if you release the force, the object goes back to its original dimension. Okay, after the elastic limit it does not go back to its original dimension. Okay, okay, fine. So write this of two types. You have written this. Okay, now see, यहां तक लिख लिया, टेंजेंशियल स्ट्रेस तक लिख लिया है ना, टेंजेंशियल स्ट्रेस तक. लिख लिया, ठीक है. ऑनलाइन पीपल, यू हैव रिटन टिल टेंजेंशियल स्ट्रेस. ओके, एक्चुअली देयर आर, तुमने टू टाइप्स जहां पे लिखा है ना, उसको थ्री टाइप्स कर लो, ठीक है. जहां पे टू लिखा है उसको थ्री कर लो. तीसरा वाला है, लिखो वॉल्यूम, नहीं आइसो, वॉल्यूमेट्रिक स्ट्रेस, वॉल्यूमेट्रिक स्ट्रेस. अभी इसके बाद ये देखो स्क्रीन, ठीक है. So let's say this is your iron bar, okay, iron bar, iron rod, whatever it is, okay, and you apply a force like this. This is F external, okay, and internally there is F internal developed, okay. Then this F internal divided by the area, cross section area of this, okay, is equal to stress, right? यहाँ पे this is called longitudinal stress. पहला वाला वही था ना, longitudinal stress, normal stress और longitudinal stress. इसमें क्या होता है, the atom जो separate हो रहा है ना, the atom are separating in this direction, horizontal direction, right? And the force is also in the horizontal direction. ठीक है, ये लिखो. मतलब the force and the atom separation is in the same direction.
So can you repeat?
I said the atom separation is in the same direction as the force applied. ठीक है, ठीक है, ओके. और मूवमेंट ऑफ एटम, एक्चुअली सेपरेशन जरूरी नहीं है, हो सकता है कंप्रेस भी कर रहे हो तो कंप्रेस भी होता है, ठीक है. There is something called tangential stress. What is tangential stress? Is, let's say there is a block, okay, there is a block of you can see it in thick books. If you so if you take a thick book, okay, keep it horizontal, like the pages are like this, okay, okay, binding is here, thick book, and then what you do is you put your hand here and then apply a force like this. If you apply a force like this, the book will turn, you know, it will become like this, okay? It will become like this, okay. So इसमें क्या होता है कि the force is applied parallel to area, is applied parallel to area, इसमें force is applied perpendicular to area, okay. That's why it's called tangential stress. क्या tangent है? Force is tangent to area, okay. Parallel or tangent, okay. You also make this, okay, this becomes, after the, it becomes like this, okay, the book becomes like this. ठीक है बच्चों, got it? Next thing is this is called volumetric stress. It is also called isometric or bulk stress. I'll give you the name, okay. I forgot, huh? Hydraulic, oh, it is called hydraulic stress. The third one is called hydraulic. वॉल्यूमेट्रिक के भी लिखो और उसमें ब्रैक ऑब्लिक भी डाल दो और हाइड्रोलिक भी लिख दो. hydraulic stress, okay. What is hydraulic stress? Suppose you have a suppose this is water, okay, and this is water, deep water. Hello, I'm under the water. So this is deep water, okay. The water is running deep, okay. If you have a bubble, okay, if you release a bubble from the bottom of the water, it'll rise up. When it rises up, it becomes bigger in size. पहले तो ये observation लिखो. It happens, okay. Bubbles become bigger in size when they rise in water. कौन सा bubble? Air bubble, ठीक है. ठीक है. See, this happens because देखो pressure at the bottom is more than pressure at the top. Pressure at bottom is more than pressure at the top. Okay. So what happens is, if the, you can also think of it reverse way, कि if you take a bubble to bottom of the ocean, it decreases in size. So what is happening, देखो बबल के बारे में सोचो, बबल का पहले वॉल्यूम था v, तुम नीचे लेके गए तो वॉल्यूम कम हो गया ना. क्यों कम हो गया? बिकॉज व्हाट इज एक्टिंग एवरीवेयर, द प्रेशर इज एक्टिंग, राइट. सो दिस प्रेशर, और देखो दिस प्रेशर, स्ट्रेस का यूनिट मतलब डायमेंशन क्या है? फोर्स बाय एरिया, राइट. तो प्रेशर इज ऑलरेडी फोर्स बाय एरिया ना. सो देयरफॉर द हाइड्रोलिक स्ट्रेस इज जस्ट प्रेशर. It is just the pressure, okay? It is P. Hydraulic stress acts on all sides. लिखो. Hydraulic stress acts on all sides. Okay. Hydraulic stress acts on all sides. Done. Okay. Now we'll go to strain, and we will go to Hooke's law, and then yeah, probably that's it for today. So strain, what is strain? So right, what is strain? ठीक है, लिखो strain क्या है, नीचे लिखो. Till now we have seen cause of the deformation, okay, and right, stress is the cause of deformation. Stress is the cause of deformation. Then what is the strain? Strain is the effect of deformation. Okay, there is a cause and effect relationship between stress and strain. Strain is the effect of deformation. Okay, and let's go back to some physics, basic physics. Second law. What is second law of Newton's? Rate of change
Sir,
of
F is equal to ma.
F equal to ma. When you apply force on an object, it accelerates. What is the cause here? External force. What is the effect here? The motion, right? The acceleration. So Newton's second law is basically the effect, cause is proportional to effect. The cause is proportional to effect. Same Hooke's law, cause is proportional to effect. So stress is proportional to strain. ये Hooke's law अभी आएगा, अभी नहीं है, थोड़ी देर में. पहले let us see what is strain. Strain effect है. Effect मतलब किस, तुम stress, what was stress trying to do? Deform. तो effect क्या होगा? Deformation. How do we measure deformation? Stress is like strain is always relative. देखो strain is always relative. Strain is always relative. ठीक है? Strain is equal to change in dimension by original dimension. Strain is equal to change in dimension by original dimension. ठीक है? Change in dimension by original dimension. So we have three kind of stress है, तो three kind of strain भी है. क्या क्या strain होंगे? Three strain के types क्या हैं? नहीं, जाके stress के type देखो क्या क्या थे. पहला था stress था normal longitudinal ना, normal oblique longitudinal. strain stress था, तो वैसे ही normal longitudinal strain हो जाएगा. सेकेंड क्या था? टेंजेंशियल स्ट्रेस था, तो इसको टेंजेंशियल स्ट्रेन हो जाएगा. और थर्ड था हाइड्रोलिक स्ट्रेस, तो उसको बोलते हैं वॉल्यूमेट्रिक स्ट्रेन बोलते हैं. ठीक है, वॉल्यूमेट्रिक स्ट्रेन बोलते हैं, हाइड्रोलिक स्ट्रेन नहीं बोलते हैं. एक और चीज है, जाके एडिट कर लो, जो टेंजेंशियल स्ट्रेस था उसमें जाके ऑब्लिक शियर भी लिख लो. शियर, ओके, SHEAR ऑब्लिक है, दोनों सही है, टेंजेंशियल भी सही है, शेयर भी सही है, तो इसीलिए टेंजेंशियल और शेयर स्ट्रेन भी सही है। ओके
सर इसका करेक्शन है नॉट शॉर्ट।
क्यों इतना जल्दी, इतना देर? एक मिनट। वन सेकंड, किसका किससे ग्रेविटेशन कराना है?
रियल का कराना है।
Stress, volume, strain, हाँ. Normal strain is simply change it. So when you try to longitudinal, when you put a normal stress, the object extends. So simply it is delta L by L. The change in length by the original length. Delta L by L. Okay. Also understand this normal का मतलब है, normal का मतलब क्या होता है? Word meaning perpendicular. So the force must be perpendicular to the area. Okay. If it is not perpendicular, you take the component which is perpendicular. Fine. ठीक है, टेंजेंशियल स्ट्रेन देखो कितना होता है, ये जो बुक है ना, इस बुक को व्हेन यू अप्लाई लाइक दिस, नो हॉरिजॉन्टल फोर्स व्हेन यू अप्लाई, सी व्हिच पार्ट हैज deformed. This part is deformed the most, right? This point was supposed to be here, but now it is here. So this distance is x and this distance is L. So the tangential stress is x by L. तो ये x क्या है? In the direction of force. और L क्या है? Perpendicular direction of the force. Okay, so this is important that shear strain is x by L. इसमें x क्या होता है? X is parallel to force and L is perpendicular to force. Yeah, everyone has understood. Hi. Hmm? Yeah. Volume strain होता है. You're trying to change the volume, right? So it is delta V by V. Delta V by V. There is change in volume by the original volume. Okay. ठीक. सबको ये समझ में आ गया? Press. Pressure. अभी okay. Now what is Hooke's law? अपने को पता है cause is proportional to effect. Yes or no? है ना? तो cause क्या है यहाँ पे? स्ट्रेस है, प्रोपोर्शनल टू स्ट्रेन. अब स्ट्रेस है, अब प्रोपोर्शनल साइन को हटाना है तो क्या लिखेंगे? इज इक्वल टू सम कांस्टेंट. दैट कांस्टेंट का नाम यहाँ पे होता है ई, ई के कुछ भी, ठीक है, इनटू स्ट्रेन. ठीक है, ये इतना समझ में आया सबको? अब सुनो इंपॉर्टेंट चीज. द इंपॉर्टेंट चीज इज गिव मी द बुक फर्स्ट. गिव मी द बुक. यस, दिस बुक.
So what is that? Strain is equals to E strain.
नाइस. ओ सॉरी सॉरी, गलत लिख दिया. I just sometimes stress is equal to E strain. स्ट्रेस इक्वल टू ई स्ट्रेन, ठीक, वो नहीं है। Y in shear it is called G, and in bulk it is called B. Yeah. So there are three types of stresses and strain, right? In the case, so stress is generally called sigma. This unit, ये इसका symbol, और strain का general होता है ये epsilon, ठीक है? इसको बोलते हैं सिग्मा, इसको बोलते हैं एप्सिलॉन, ठीक है? फाइन। अलग अलग केस में, फॉर एग्जांपल इन लॉन्गिट्यूडनल, ये जो ई होता है इसको बोलते हैं वाई, क्या बोलते हैं? वाई। इन द केस ऑफ शियर इट इज कॉल्ड जी, ठीक है? एंड इन द केस ऑफ इट इज कॉल्ड बी, ठीक है? नाउ हाउ डू वी राइट दीज इक्वेशंस इन देयर respective you know cases is, तो ये किसके सिंबल है? ये ई के प्रोपोर्शनैलिटी के सिंबल हैं, ये वाई जी और बी। पहला वाला क्या है? लॉन्गिट्यूडनल फर्स्ट, सेकंड क्या है? शियर टेंजेंशियल, थर्ड क्या है? वॉल्यूमेट्रिक या हाइड्रोलिक, ठीक है? तो पहले वाले केस में, फर्स्ट केस में राइट सिग्मा इज वेरी सिंपल, वाई टाइम्स एप्सिलॉन, ठीक है? इज एवरीवन गेटिंग दिस? yes or no? Hello, everyone is getting this? Online people, ठीक? And how do we, if you know this is a rod, ये रॉड का क्रॉस सेक्शन एरिया ए है, ठीक है? क्रॉस सेक्शन एरिया ए है, इसका लेंथ एल है, फिर तुमने इसको खींचा, इस पे फोर्स लगाया एफ, ठीक है? फोर्स लगाया एफ फोर्स लगाने से क्या हुआ कि ये बढ़ गया, कितने से बढ़ गया? डेल्टा एल से बढ़ गया, ठीक? सो व्हाट इज द स्ट्रेस यू हैव अप्लाइड? द स्ट्रेस यू हैव अप्लाइड इज एफ बाई ए, यस और नो? समझ में आ रहा है? एंड द स्ट्रेन इसमें डेवलप हुआ, सॉरी कितना हुआ वो? डेल्टा एल बाई एल, ठीक है? So therefore you will write F by A stress is equal to Y times delta L by A. This is a very important equation. It will be used many times. Remember this. It is coming from this only. It is this only. Okay. Stress is F by A. Y times epsilon is delta L by L. Cool. Done. Next is if you have second वाला क्या था? Second इधर देखो, second इधर आओ, इसमें shear था ना, shear में देखो, तुम ये निकाल रहे हो, देखो ये देखो, ध्यान से देखना डायग्राम में, डायग्राम देखो, डायग्राम। The shear strain was x by L, no? And if this is theta, x by L is also equal to tan theta. So x by L is tan theta. You understand this, right? So I'll use this आगे, okay? So the strain is, in the case of second, the strain is easy. Strain is what? It is x by L. It is equal to tan theta. Yes or no? Okay. And the stress is again sigma what? Okay, F. F by A into G theta. Okay. So this is written as sigma is equal to G times tan theta. It is also equal, पहले तो लिखूंगे Gx by L, which will be G times of tan theta, right? देखो for small angles, because this deformation is very less, okay? The x is very less, so the theta is also very less. Do you understand? If x is very less, the theta is also very less. For small angles, theta is approximately equal to tan theta. for small thetas, theta is approximately equal to tan theta. So you can replace this tan theta by just theta. So you get y is equal to g theta. और ये theta should be in radians, ये लिख लेना. ठीक है? Just now the next is bulk modulus. So see, if you have, let's say, if you have in water, you are applying pressure to a drop of bubble, okay, and what happens from its original volume the V, and then its volume changed to its volume decreased by delta V. So the new volume V final will be V minus delta V, and V initial is how much? V. Okay, so what is the change in volume? It is delta V, no? Correct, delta V, no? Okay, is delta V positive or negative? Yeah, here delta V is negative, no? Because the volume has decreased, no? Fine. इसका जो इक्वेशन है वो इक्वेशन है स्ट्रेस इज इक्वल टू P टाइम्स स्ट्रेन, ये होना चाहिए, राइट? स्ट्रेस, इसका इक्वेशन होना चाहिए, इसका स्ट्रेस इज इक्वल टू B टाइम्स स्ट्रेन. अब स्ट्रेस कितना है यहाँ पे? फोर्स बाय एरिया. इन 3D it is what? In volumetric it is pressure. So it is pressure is equal to B times strain. कितना है यहाँ पे? डेल्टा V by V. ठीक है. अब इसमें प्रॉब्लम है, ये पॉजिटिव क्वांटिटी की नेगेटिव क्वांटिटी है? प्रेशर पॉजिटिव. B कैसा क्वांटिटी है? पॉजिटिव है. B तो मॉडुलस है. V कैसा क्वांटिटी? वॉल्यूम पॉजिटिव. तो ये तो नहीं हो सकता कि डेल्टा V यहाँ पे हो, इसलिए यहाँ पे माइनस होता है. ठीक है? Understood why there is a minus here? Because delta V is negative quantity, we have to adjust for the sign. So P is minus B times delta V by V. ठीक? और therefore B का वैल्यू कितना होगा बताओ? P by delta V by V with a negative sign. Yes or no? ये bulk modulus का definition है, एग्जाम में आएगा. What is bulk modulus? ये समझ में आ गया इतना? ओके. अभी आई थिंक इफ यू हैव, एक काम करना तुम लोग, एग्जाम्पल में समझाता हूँ, ठीक है? 9.1 9.2 इन योर बुक, दे आर देयर. ओके, आई एम एक्सप्लेनिंग. तो एग्जाम्पल 9.1 देखो क्या है. अ स्ट्रक्चरल स्टील रॉड लिखो, अ रॉड बनाओ जल्दी से. as a R is 10 millimeter. Okay, इसमें units are important in this chapter. Okay, what is millimeter, what is meter, and as a length of 1 meter. So L is 1 meter. ठीक. 100 kilonewton force stretches along its length. तो force ऐसे लग रहा है, कितना लग रहा है? 100 kilonewton. Kilonewton means 10 power 5 newton. Okay, is it okay with everyone? Find the stress. पहला stress है. स्ट्रेस क्या होता है? फोर्स बाय एरिया. फोर्स कितना? 10⁵. एरिया कितना है? पाई आर स्क्वायर. पाई, अब रेडियस कितना? 10 मिलीमीटर. कैसे लिखेंगे? 10 इंटू 10 पावर -3 और -4, -3, नो? सो इट इज 10 पावर -2 मीटर. सो एरिया आएगा पाई इंटू 10 पावर -2 स्क्वायर. इज एवरीवन गेटिंग दिस और नॉट? किसी को डाउट है इसमें? जय, तुमको डाउट है इसमें? नहीं है? रियल नहीं है? ठीक. तो इसका आंसर आएगा कुछ तो जो भी आएगा इस कैलकुलेट करके 10⁹ एक तो ऊपर आएगा, ठीक है ना, और भाई पाई आएगा. ठीक है. इसको कैलकुलेट करोगे तो आएगा 3.18 इंटू 10 पावर 8 न्यूटन पर मीटर स्क्वायर। इज अ वेरी हाई स्ट्रेस। ओके, फिर पूछता है, फिर बोलता है कि क्वेश्चन में दे रखा है द यंग मॉडुलस कितना है, 2 इंटू 10 पावर 11 न्यूटन पर मीटर स्क्वायर। पूछ रहा व्हाट इज द इलोंगेशन। इलोंगेशन मतलब डेल्टा एल और डेल्टा एल बाई एल। डेल्टा एल, जस्ट डेल्टा एल, इलोंगेशन। ओके, इलोंगेशन डेल्टा एल, तो क्या लिखेंगे, the stress F by A is equal to y times of delta L by L. You already found the F by A. ठीक है, okay, don't put F by A again. Okay, just directly put stress. It is 3.18 into 10 power 8 is equal to y की value 2 into 10 power 11 into delta L का निकालना है, L है 1 meter. ठीक है, now delta L, if you see, you will see delta L comes out to be this value divided by 2 into 10 power 11, and as you can see it is a very low value. ठीक है, the delta L which comes out in this question is 1.59 mm and it is a very low value. Okay, usually ऐसे ही आता है, तो ऑर्डर भी याद रखो। तुम्हारा डेल्टा एल 3 सेंटीमीटर 5 मीटर ऐसे सब नहीं आना चाहिए, मिलीमीटर के ऑर्डर में आना चाहिए। ठीक है, डेल्टा एल। ठीक है, तो स्ट्रेन भी पूछ रहा है, स्ट्रेन इज जस्ट डेल्टा एल बाई एल, कितना है 1.59 mm बाई 1 मीटर, राइट। तो ये डेल्टा एल बाई एल एज इट इज इतना सही है। if they are also asking percentage, you multiply it by 100. If they're not asking percentage, just keep it like this. Strain should not be reported in percentage. If you want it, you can report it. Okay, understood everyone? Example 2, a copper wire of length, कितना length है 2.2 meter and steel wire of length 1.6 meters. So there is copper, there is steel of 1.6 meter connected end to end, both of diameter 3. So R is 1.5 mm, both का radius. Okay, इसका भी. When stretched by a load, the net elongation is found to be 0.7. Obtain the load applied. So right, when two wires are connected in series, what is same for them? It is the given है यहाँ पे. Two wires are connected. ये दो वायर को सीरीज में कनेक्ट किया, and then you are applying force like this. So what is same for both of them? Yes, the force is same. The force is same for both of them, right? The deformation force is same for both of them. ठीक है, सो इसका भी डेल्टा L1 होगा, इसका भी डेल्टा L2 होगा, और दिया है कि डेल्टा L1 द नेट इलोंगेशन इज 70.7 mm, 0.7 mm. तो पहले वाले के लिए क्वेश्चन लिखेंगे F by A इज इक्वल टू y1 टाइम्स डेल्टा L1 by L. ठीक है, L1. ठीक है, दूसरे लिखेंगे F by A इज इक्वल टू y2 टाइम्स डेल्टा L2 by L2. चलो अब पूछता हूं मैं, इसमें F का वैल्यू तो नहीं पता, ठीक, A का वैल्यू कितना है, सेम बोथ ऑफ देम है कितना, एरिया है ना, क्रॉस सेक्शन एरिया, जोर से बोलो। क्या बोल रही हो, पाई आर स्क्वायर है ना, पाई इंटू व्हाट इज रेडियस, मीटर, यस, into pi, correct. So the area is 1.5 square, 1.5 into 10 power minus 3 का whole square into pi, that is the area, right? ये area डालेंगे यहाँ पे, y1 का वैल्यू ना इस क्वेश्चन में नहीं दिया है, बट एक्चुअली वो टेबल से ढूंढ के निकालना है, दे रखा होगा क्वेश्चन में, y1 दे रखा होगा, ठीक है। y1 का वैल्यू डालना है और l1 का वैल्यू डालना है। l1 वैल्यू कितना है 2.2, तो यहां से आपको क्या मिलेगा, डेल्टा l1 मिलेगा इन टर्म्स ऑफ f। यू विल गेट डेल्टा l1 है सम नंबर इनटू f, राइट, डू यू अंडरस्टैंड, समथिंग इनटू f मिलेगा। सिमिलरली डेल्टा l2 समथिंग इनटू f मिलेगा, दोनों को ऐड कर दोगे, डेल्टा l1 प्लस डेल्टा l2 ऐड करोगे तो यहाँ पे आएगा, लेफ्ट साइड आएगा 0.7 और राइट साइड आएगा सम नंबर इनटू f प्लस सम नंबर इनटू f, f कॉमन ले लोगे, ओके, आंसर आ जाएगा, ठीक है। हम्म, पहले तो ये लिखो GPA, the value of lead for shear modulus of lead is, लिखो, the shear modulus of lead is 10 पावर 5.6 GPA। इधर पे जो GPA है दैट इज कॉल्ड गीगा पास्कल, लिखो, GPA is गीगा पास्कल। गीगा मींस गीगा, गीगा is 10 power 9। So G actually value is 5.6 into 10 power 9 Pascal, okay। फिर लिखो एक स्क्वायर, स्क्वायर स्लैब है, स्क्वायर लेड स्लैब ऑफ साइड 50 सेंटीमीटर, स्लाइड ऑफ साइड 50, ये 50 बाई 50 है, ठीक है। इसका थिकनेस जो है वो 10 है, ठीक है। So this is 10 cm is subject to a shearing force on its narrow face, on its narrow face, narrow face क्या है, हाँ, ओ 10 वाला साइड है ना, तो गलत बनाया है फिर, ऑन इट्स नैरो फेस लिखा है तो 50-50, हाँ ऐसा है, देखो ऐसा है कि ये 50-50 है, ठीक है, 50-50, और ये है 10, ठीक, अंडरस्टूड। अभी दिस एंड इज फिक्स्ड, द लोअर एंड इज फिक्स्ड ऑन द ग्राउंड एंड अप्लाइंग अ स्ट्रेस लाइक दिस, ठीक है। सो यू आर अप्लाइंग इट ऑन विच सरफेस, यू आर अप्लाइंग ऑन दिस सरफेस, ठीक है। इस सरफेस का एरिया कितना है, 50 इंटू 10, 500 सेंटीमीटर स्क्वायर, ये सुनो। क्वेश्चन बोल रहा है कि इस पे ना एक फोर्स लगाया, कितना फोर्स लगाया, शेयरिंग फोर्स लगा रहा है 9 इंटू 10 पावर 4 न्यूटन, क्या है 9 इंटू 10 पावर 4 न्यूटन, ठीक है। कितना फोर्स लगाया, तो पूछ रहे कितना ये एंड कितना डिस्प्लेस होगा, यू नो हाउ मच दिस विल डिस्प्लेस्ड, अंडरस्टूड। तो यहाँ पे ऐसे देखो कि आ, Hmm. The stress is force by area. Force कितना है 9 into 10 power 4 डिवाइड बाय एरिया कितना है 500 सेंटीमीटर स्क्वायर को यू विल हैव टू कन्वर्ट इनटू मीटर स्क्वायर. Yeah, 500 into 10 power minus 4 meter square. You'll get some stress applied. Stress आएगा 1.8 into 10 power 6 Newton per meter square. And this is 19 per 4 Newton. Sorry, this sigma is this, stress is this. Okay, and you have sigma is equal to g theta, right? Or you can also write g theta, g x by L. Okay, so here you will have to use x by L. So sigma का value है 1.8 into 10 power 6 is equal to
क्या
g 5.6 into 10 power 9 into x by L, and this L you will put as 50. Okay, to find x. Sorry, 16 सेंटीमीटर नहीं आ रहा है, 0.16 mm आ रहा है, mm मीटर में. Yeah, you should take 0.5 L as 0.5. Correct. You have sigma is g theta. ठीक है. Are you guys ये था समझ में आ गया सब? ठीक है. Next class we will do we will start with what we'll start with. We'll start with Hooke's law. Okay, we'll start with Hooke's law. Today we have to do what you have to do is see the WhatsApp group. See the WhatsApp group. Can you hear me, online people?
Yes, sir.
WhatsApp ग्रुप में आज एक डाला है लिंक, दिखा? आज डाला है मैंने एक लिंक mphysicstutorial.com. मिल गया? ये अभी लिखना है, ठीक है, पूरा लिखना है. ठीक. दूसरी चीज, ये होमवर्क नहीं है, एक चीज दूसरी बता देता हूँ. I hope every one of you can access the Google Classroom. Yes or no? No. If you can't access the Google Classroom, who cannot access the Google Classroom? You cannot. Anyone else who cannot? Yeah. Aditi, naam hai na, Ganti. You are there. You can access. Or you, hello. 1 second. Dhwani. See the link. Click on the link. You will be able to access. Okay. You'll be able to access, and then after that you will see this is your homework for today. Okay, the homework for today is you will see mechanical properties solid. You'll go to lectures. Okay, when you go to lectures, I will पहले वो ज्वाइन कर लिया ध्वनि. अब ग्रुप पे जो लिंक है वो ज्वाइन करो, वो खोलो एक बार. ग्रुप पे जो लिंक है वो खोलो, अभी भेजा. क्या दिखा? लेक्चर्स दिखा मैकेनिकल प्रॉपर्टीज सॉलिड का. क्या खुला उससे? अच्छा, जनरल क्लासरूम ही खुल गया. देखो फिर I'll send it again. Okay. इस लिंक से खोलो, ठीक है? The second link which I showed. Click the most recent link. What do you see? Yeah, वो stress introduction घर पे बैठ के करना है, ठीक है? Stress introduction घर पे बैठ के करना है. Fine. अब बोलो. तो पेपर उठा लो. यहाँ पे पेपर होगा कहीं. What is your proposed solution? No. That is not this. 8:15 the class ends. You'll end it. Go at 8:15. Take a paper. ठीक है. Right. Now gravitation वाला notes complete करो, ठीक है? लिखो उसको, यहाँ भेजो और फिर चले जाओ. Gravitation वाला right now. You have to write the gravitation notes right now. Send it to me, online people, and bye. Okay.
Sir, can you send it in the chat as